The Intel 4004 is a 4-bit central processing unit released by Intel Corporation in 1971. It was the first commercially available microprocessor by Intel. The chip design started in April 1970, when Federico Fagan joined Intel, and it was completed under his leadership in January 1971. The first commercial sale of the fully operational 4004 occurred in March 1971 to Busicom Corp. of Japan, for which it was originally designed and built as a custom chip. In mid-November of the same year, with the prophetic ad announcing a new era in integrated electronics, the 4004 was made commercially available to the general market. The 4004 was history's first monolithic CPU, fully integrated in one small chip. Such a feat of integration was made possible by the use of the then-new silicon gate technology, which allowed twice the number of random logic transistors and an increase in speed by a factor of 5 compared to the incumbent technology. The 4004 microprocessor was one of 4 chips constituting the MCS4 chipset, which included the 4001 ROM, 4002 RAM, and 4003 shift register. With these components, small computers with varying amounts of memory and I/O facilities could be built. 3 other CPU chip designs were done at about the same time. The 4-phase system AL1, done in 1969, the MP944, completed in 1970, and used in the F-14 Tomcat fighter jet, and the Texas Instruments TMS-1000 chip, announced in September 17, 1971. Both the AL1 and the MP944 used several chips for the implementation of the CPU function. The TMS-1000 chip, presented as a calculator-on-a-chip, with the designation TMS-1802NC, was first used commercially in a T-calculator products introduced in 1972. This chip contained a very primitive CPU which could only implement a variety of simple 4-function calculations. It was the precursor of the TMS-1000, introduced in 1974, which is considered the first microcontroller, i.e., a computer on a chip containing not only the CPU, but also ROM, RAM, and I/O functions. The MCS4 family of 4 chips developed by Intel, of which the 4004 was the CPU or microprocessor, was far more versatile and powerful than the single-chip TMS-1000, allowing the creation of a variety of small computers for various applications. The MCS4 was eventually superseded by powerful microcontrollers like the Intel 8048 and the Zilog Z8 in 1978-1979. The architecture of this processor formed the basis for later models of microprocessors. History and production. The first public mention of 4004 was an advertisement in the November 15, 1971 edition of Electronic News, though unconfirmed reports put the date of first delivery as early as March 1971. Packaged in a 16-pin ceramic dual inline package, the 4004 was the first commercially available computer processor designed and manufactured by chip maker Intel, which had previously made semiconductor memory chips. The chief designers of the chip were Federico Fagan, who created the design methodology and the silicon-based chip design, Ted Hoff, who formulated the architecture, both of Intel, and Masato Shishima of Busicom, who assisted in the development. Fagan, the sole chip designer among the engineers on the MCS4 project, was the only one with experience in MOS random logic and circuit design. He also had the crucial knowledge of the new silicon gate process technology with self-aligned gates, which he had created at Fairchild in 1968. At Fairchild in 1968, Fagan also designed and manufactured the world's first commercial IC using Sargent, the Fairchild 3708. As soon as he joined the Intel MOS department, he created a new random logic design methodology based on silicon gate, and contributed many technology and circuit design inventions that enabled their single-chip microprocessor to become a reality. His methodology set the design style for all the early Intel microprocessors and later for the Zilog Z80. He also led the MCS4 project and was responsible for its successful outcome. Martian Ted Hoff, head of the Application Research Department, contributed the architectural proposal for BusyCom working with Stanley Marzer in 1969. Then he moved on to other projects. When asked where he got the ideas for the architecture of the first microprocessor, Hoff related that Plessey, a British tractor company, had donated a mini-computer to Stanford, and he had played with it some while he was there. Shima designed the BusyCom calculator firmware and assisted Fagan during the first 6 months of the implementation. The manager of Intel's MOS design department was Leslie L. Vadars. At the time of the MCS4 development, Vadash's attention was completely focused on the mainstream business of semiconductor memories, and he left the leadership and the management of the MCS4 project to Fagan. BusyCom had designed their own special-purpose LSI chipset for use in their BusyCom 141 PF calculator with integrated printer, following the architectural model of the Olivetti Programmer 101, the world's first tabletop programmable calculator, introduced in 1965, and commissioned Intel to develop it for production. However, Intel determined it was too complex, since serial memories required more components, and would use 40 pins, a packaging standard different from Intel's own 16-pin standard, and so it was proposed that a new design produced with standard 16-pin DIP packaging and reduced instruction set be developed, using Intel's newly developed dynamic RAM memory. This resulted in the 4004 architecture, which was part of a family of chips, including ROM, DRAM, and serial-to-parallel shift-registered chips. The 4004 was subsequently designed using silicon gate technology and built of approximately 2,300 transistors, and was followed the next year by the first ever 8-bit microprocessor, the 3500 transistor 8008. It was not until the development of the 40-pin 8080 in 1974 that the address and data buses would be separated, giving faster and simpler access to memory. The 4004 employed a 10 micrometers process silicon gate enhancement load PMOS technology and could execute approximately 92,000 instructions per second. A single instruction cycle was 10.8 microseconds. The original clock rate design goal was 1 MHz, the same as the IBM 1620 Model I. The Intel 4004 was designed by physically cutting sheets of ruby lithe into thin strips to lay out the circuits to be printed, a process made obsolete by current computer graphic design capabilities. Name and variants. When Fagan designed the MCS4 family, he also christened the chips with distinct names: 4001, 4002, 4003, and 4004, breaking away from the numbering scheme used by Intel at that time, which would have required the names 1302, 1105, 1507, and 1202 respectively, had he followed Intel's number sequence. The idea that the chips were part of a family of components intended to work seamlessly together would have been lost. Intel's early numbering scheme for integrated circuits used a 4-digit number for each component. The first digit indicated the process technology used, the second digit indicated the generic function, and the last 2 digits of the number were used to indicate the sequential number in the development of the component. The 8008 microprocessor was originally called 1201, per Intel's naming conventions. Before its market introduction, the 1201 was renamed 8008, following the new naming convention started with the 4001 halves, 3/4, Tadashi Sasaki attributes the basic invention to break the calculator into 4 parts with ROM, RAM, shift registers and CPU to an unnamed woman from the Nara Women's College present at a brainstorming meeting that was held in Japan prior to his first meeting with Robert Noyce from Intel, leading up to the Busicom deal. The 4004 was part of the MCS4 family of LSI chips that could be used to build digital computers with varying amounts of memory. The other members of the MCS4 family were memories and input-output circuits, which are necessary to implement a complete computer. The 4001 was a ROM with 4 lines of output. The 4002 was a RAM with 4 lines of input-output. The 4003 was a static shift register to be used for expanding the I/O lines, e.g., for keyboard scanning or controlling a printer. The 4004 included control functions for memory and I/O, which are not normally handled by the microprocessor. Technical specifications. Maximum clock rate was 740 kHz. Instruction cycle time, 10.8 microseconds. Instruction execution time 1 or 2 instruction cycles, 46,300 to 92,600 instructions per second. Adding 2 8-digit numbers was stated as taking 850 microseconds, i.e., 79 instruction cycles, about 10 instruction cycles per decimal digit. Separate program and data storage. Contrary to Harvard architecture designs, however, which use separate buses, the 4004, with its need to keep pin count down, used a single multiplexed 4-bit bus for transferring 12-bit addresses, 8-bit instructions, 4-bit data words, able to directly address 5,120 bits of RAM, stored as 1284-bit characters, and organized into groups representing 1024 data and 256 status characters, able to directly address 32,768 bits of ROM, equivalent to and arranged as 4,096 8-bit characters. Instruction set contained 46 instructions. Register set contained 16 registers of 4 bits each. Internal subroutine stack 3 levels deep. Support chips 4001, 256-byte ROM, and 1 built-in 4-bit I/O port. A 4001 ROM plus I/O chip cannot be used in a system along with a 4008-4009 spare, 4002. 40-byte RAM, and 1 built-in 4-bit output port. The RAM portion of the chip is organized into 4 registers of 24-bit words, 16 data words, 4 status words. 4003. 10-bit parallel output shift register for scanning keyboards, displays, printers, etc. 4008. 8-bit address latch for access to standard memory chips, and 1 built-in 4-bit chip select and I/O port. 4009. Program in I/O access converter to standard memory and I/O chips. 4269. Keyboard display interface. 4289. Memory interface. The minimum system specification was described by Intel as consisting of a 4004 with a single 256-byte 4001 program ROM. There was no explicit need for separate RAM in minimal complexity applications thanks to the 4004's large number of onboard index registers, which represented the equivalent of 16 by 4-bit or 8 by 8-bit characters of working RAM, nor for simple interface chips thanks to its built-in I/O lines. However, as project complexity increases, the various other support chips start to become useful. Packaging. Numerous versions of the Intel MCS4 line of processors were produced. The earliest versions were ceramic and used a zebra pattern of white and gray on the back of the chips. The next generation of the chip was plain white ceramic. Current versions of MCS4 family are produced with plastic. Collectors of these chips have peaked in recent years due to the significance that is associated with this achievement. Use. The first commercial product to use a microprocessor was the Busicom Calculator 141PF. According to Nick Tredennick, a microprocessor designer and expert witness to the Boone-Hyatt patent case. Here are my opinions from the study I conducted for the patent case. The first microprocessor in a commercial product was the four-phase systems AL1. The first commercially available microprocessor was the 4004 from Intel. A popular myth has it that Pioneer 10, the first spacecraft to leave the solar system, used an Intel 4004 microprocessor. According to Dr. Larry Lasher of Ames Research Center, the Pioneer team did evaluate the 4004, but decided it was too new at the time to include in any of the Pioneer projects. The myth was repeated by Federico Faggin himself in a lecture for the Computer History Museum in 2006. Legacy and Value. On November 15, 2006, the 35th anniversary of the 4004, Intel celebrated by releasing the chip's schematics, mask works, and user manual. On October 15, 2010, Faggin, Hoff, and Mazza were awarded the National Medal of Technology and Innovation by President Barack Obama for their pioneering work on the 4004. Patents. US 3,753,011 August 14, 1973. Faggin, Federico. Power supply settable bistable circuit. US 3,821,715 June 28, 1974. Hoff, Martian, Mazza, Stanley, Faggin, Federico. Memory system for multi-chip digital computer. Historical documents. Faggin F. Capocachi RF. A new integrated MOS shift register. Proceedings 15 International Electronics Scientific Congress, Rome, April 1968, pp. 143-152. This paper describes a novel static MOS shift register, developed at SGS Fairchild at the end of 1967, before Federico Faggin joined Fairchild's R&D in Palo Alto in February 1968. Faggin later used this new shift register in the MCS4 chips, including the 4004. Cover an abstract of the IEDM program. The silicon gate technology was first presented by its developer, Federico Faggin, at the IEDM on October 23, 1968 in Washington, D.C. It was the only commercial process technology for the fabrication of MOS integrated circuits with self-aligned gate that was later universally adopted by the semiconductor industry. The Sargent was the first technology to produce commercial dynamic RAMs, CCD image sensors, non-volatile memories and the microprocessor, providing for the first time all the fundamental elements of a general-purpose computer with LSI integrated circuits. Cover of Electronics magazine. The Electronics article introduces the Fairchild 3708, designed by Federico Faggin in 1968. It was the world's first commercial integrated circuit using the silicon gate technology, proving its viability. Initials FF. On the 4004 design. The 4004 bears the initials FF of its designer, Federico Faggin, etched on one corner of the chip. Signing the chip was a spontaneous gesture of proud authorship and was also an original idea imitated after him by many Intel designers. Busicom 141 PF printing calculator engineering prototype. The CHM collection catalog shows pictures of the engineering prototype of the Busicom 141 PF desktop calculator. The engineering prototype used the world's first microprocessor to have ever been produced. This one-of-a-kind prototype was a personal present by Busicom's president Mr. Yoshio Kojima to Federico Faggin for his successful leadership of the design and development of the 4004 and three other memory and I/O chips. After keeping it in his home for 25 years, Faggin donated it to the CHM in 1996. F. Faggin and M.E. Hoff. Standard parts and custom design merge in 4-chip processor kit. Electronics, April 24, 1972, pp. 112-116. Reprinted on pp. 6-27 6-31 of the Intel Memory Design Handbook. August 1973. F. Fagan, Shima, M.E., Hoff Jr., Feeney, Mazza. The MCS4, an LSI microcomputer system. IEEE 72 Regen 6 Conference. Reprinted on pp. 6-32 6-37 of the Intel Memory Design Handbook. August 1973.